So in this example, we are going to be solving this equation. We have 2x squared minus 8x plus 3 equals 0, and we are specifically being asked to complete the square. Now, this is one method of solving this problem. There are several ways that you can do it, and tomorrow we're going to be learning the quadratic formula. And the quadratic formula works for every single type of quadratic. So really, you can kind of just get away with always using the quadratic formula. But there is another method, and this is called completing the square. So completing the square basically means that we're taking a quadratic that basically factors into a binomial squared. So if we take a look at the examples that we just did, right, we had x plus 1 squared. We had a binomial squared, and if I expand this, I would have x plus 1, x plus 1. I have two of the same binomial. And same thing down here in the other example that we did. We have 2x minus 5 squared, right? So two of the same binomial. And what we can do, we know that that's a special type of factoring. There are some trinomials that when we factor end up being the same binomial squared. We get two of the same binomials. So that's what we want to do here. By completing the square, we want to make sure that this trinomial is one of those trinomials that when we factor, it ends up being the same binomial squared, right? Two of them. So we're going to use that method. And the first thing that we want to do is we want to take a look here and realize that this is not already in that perfect squared trinomial form. All right, so we're going to have to do a few steps to get it into that form. And the very first thing that we want to do is we really just want to focus on these x's. All right, so this positive 3, we want to move it over to the other side. So we're going to always take the constant, and we're going to move it over to the opposite side. So now what we have is 2x squared minus 8x equals a negative 3. All right, so the first thing you want to do is move the constant. All right, you want to isolate it, you want to move it to the other side. You don't want it to be with the x's. The second thing that you have to check is that a always equals 1. All right, so here we know that a is always the coefficient of the x squared term. And right here, a is 2. So to make it 1, what we need to do is pretty simple. We just need to divide everything by that coefficient. So we're going to divide everything by 2. Right, so this technically equals 1. So we have x squared. Negative 8x divided by 2 is negative 4x. All right, I'm actually going to leave a space, so leave a space as well. And negative 3 divided by 2, don't use decimals. Let's keep it in fraction form. So that just equals negative 3 over 2. All right, so now what we need to do is the process of completing the square. So there's a formula. All right, so the formula for completing the square. All right, here it is. All we do is we take the b term, the b coefficient. So b is always the coefficient of your x, not your x squared, the x. You're going to take that number, that's a b, not a 6. You're going to divide it by 2, and then you're going to square all of that. That's the formula. All right, so let's take a look here. If I do b, which is negative 4, right, I'm going to divide it by 2, and then I'm going to square it. So negative 4 divided by 2 is negative 2, and negative 2 squared is a positive 4. Anytime you square something, you're going to get a positive. So I have a positive 4. Now remember that in math, when we do something to one side, we have to do it to the other side. All right, so I'm also going to add 4 to the right side. Okay, now the whole reason that we did that is because when we factor this trinomial right here, we're actually going to get x minus 2 and x minus 2, right? And we could really just write that as x minus 2 squared, all right? And that's the goal, right? That's what we had in the previous two examples, in number 1 and number 2. We had the same binomial squared, and that's what we want, because now we can use the method that we just used in examples 1 and 2 to solve this. So let's go ahead and just start doing some algebra. First, I need to simplify this, right? So I have negative 3 squared. I need to rewrite 4 over 1 as a fraction over 2. So I'm going to multiply everything by 2. That gives me 8 in the numerator, right? So negative 3 plus 8, that gives me a positive 5. So I have x minus 2 squared equals a positive 5 over 2. All right, now this is basically what we had in examples 1 and 2. So we can just start solving. I'm going to go ahead and square root both sides, and these will cancel. So now I have x minus 2 is equal, and remember, in front of your radical, you must have plus or minus. So I can't take the square root of 5 halves. It's not going to give me a whole number or a nice fraction, so I'm just going to leave it as the square root of 5 halves. All right. What we're going to do, one thing we could do actually, but we'll do that in, well, let's do this first. I can separate this, so I'm going to go off to the side and just show you a little bit. Remember that we can split this radical into radical 5 over radical 2, right? And the whole reason that we did all the conjugating and everything is for things like this. I need to conjugate this now. Or I'm sorry, rationalize technically, because we have a monomial. So I'm going to multiply by radical 2, and that's going to give me radical 10 over square root of 2 times square root of 2 is 2, which comes from square root of 4. So I have x minus 2 equals plus or minus radical 10 over 2. All right, so that's the rationalized version of this because we don't want radicals in our denominators and we have a denominator in a radical. All right, so we're almost done here. All we need to do is just add 2 to both sides. And remember that these are not like terms because this is a radical term and this is not. So I have 2 plus or minus radical 10 over 2. But we're going to be a little picky, all right? We would rather have one fraction or one term instead of 2. So what we can do here is we can rewrite 2, which is technically over 1. We can find a common denominator, right? So if I found a common denominator, 2 over 1 would become 4 over 2 plus or minus radical 10 over 2, right? And that can be rewritten all as one fraction. So I'm going to have x equals, in the numerator, 4 plus or minus radical 10, and my denominator is 2. Okay, now that denominator can divide into 4, but it can't divide into radical 10 because these are not like terms. These are not like each other, so they can't divide each other. So since 2 can only divide 4 and not the other one, I have to leave it like this. Remember that to simplify, this denominator has to be able to divide everything in my numerator. So this is my final answer. And remember that this actually represents 2 answers, for plus radical 10 over 2 and the second answer for minus radical 10 over 2.